Hello and welcome everyone. Thank you for joining us for this year's EngTalk, and it's brought to you by the Institute of Engineering and Technology, or the IET. My name is Wendy Watson-Wright, and I'll be hosting today's EngTalk. Among other things, I am a former Executive Secretary and Assistant Director General of UNESCO's Intergovernmental Oceanographic Commission, or the IOC, and I was the inaugural CEO of the Atlantic Canada-based Ocean Frontier Institute until retiring at the end of 2019. These days, I'm active in the ocean community as a member and gender focal point for the UN Joint Group of Experts on the Scientific Aspects of Marine Environmental Protection, or GASAMP, which you will hear about later, and a member of various boards such as the World Ocean Observatory, the International Ocean Institute, and the Marine Environmental Observation Prediction and Response Network, or MEOPAR. For today's talk, I'm very honored to say that we have Professor Stephen de Mora, who is IMarEST's first ambassador for the UN Decade of Ocean Science for Sustainable Development and a member of the UK's Marine Science Coordination Committee. Now, Stephen will tell you more about himself at the beginning of his talk, but I would like to point out that he was chair of the International Science Advisory Committee of MEOPAR, which I just mentioned, for a number of years. So I'd now like to hand over to Professor de Mora, but would remind you that during this presentation, please submit your questions in the chat box on YouTube, and we'll answer as many of them as possible at the end. So Steve, over to you.
Hello, welcome to this presentation on behalf of the Institution of Engineering and Technology. During these times of COVID-19, we've had to pre-record this presentation, but there will be a live question and answer session at the end. By way of introduction, my name is Stephen de Mora. I'm an Emeritus Fellow at Plymouth Marine Laboratory, where we're doing this filming today, but also I am for IMarEST, the Institute of Marine Engineering, Science and Technology. I am the IMarEST ambassador to the UN Decade for Ocean Science for Sustainable Development. I want to talk today about the climate and ocean, and if we consider the outline, I'll give a very brief introduction to climate change because I want to focus in particular on the impacts that climate change has on the ocean. So those impacts include warming and ocean acidification and all the downstream effects from that. I'll have a look at some of the geoengineering strategies that have been suggested and have a look at what I call the new pressures. So these are impacts on the ocean as a result of societal attempts to mitigate or combat climate change, and finish up with a very brief introduction to the UN Decade for Ocean Science. So in terms of climate change, the culprit really is atmospheric CO2. And if we look at this graph, we can see that this is known as the Keeling curve. So Charles Keeling started atmospheric CO2 measurements at Mauna Loa Observatory in Hawaii in 1958. And so now we have a slightly over 60-year time series for the atmospheric CO2. We can see during that time it's gone up nearly 100 parts per million. And you see from this, not only is the trend consistently upward, but you have the sawtooth nature of the data, which indicates the seasonality of the uptake and release of CO2 in the Northern Hemisphere. If we go back a little bit further in time, this now shows the time series for CO2. CO2 here for the last millennia, so since 1000. And we can see that up until the Industrial Revolution, it was a pretty flat curve, so at around 280 parts per million. And once the Industrial Revolution came, then that starts to take off quite considerably. The earlier data really mostly come from ice cores in Antarctica. At the same time, we see a graph for the methane, again going back to 1000 AD, and the last 1,000 years of methane, and follow the same kind of trend. flat up until the Industrial Revolution, and then it takes off quite considerably. And we'll talk a little bit more about methane later on. Its importance is that it's a much better greenhouse gas than carbon dioxide. So if we consider the ocean impacts of CO2, the carbon dioxide comes from anthropogenic activities, builds up in the atmosphere, and because it acts as a greenhouse gas, so you get heating in the atmosphere and the transfer of that heat to the ocean. So you have ocean warming. At the same time, the atmospheric CO2 can dissolve in the ocean and form carbonic acid, so you have an acidity, increased acidity as a result of the dissolution of carbon dioxide. And what we'll look at later on is the downstream effects of both of these features. So overall then, with the ocean impacts of CO2 cause physical, chemical, and biological effects. Starting off, if we consider the heat content, we can see from this graph that covers the last nearly 70 years, we can see then that the ocean has absorbed a significant amount of that heat. So the trend is upwards, just like the CO2 trend, for instance. So this is evidence of warming in the oceans. So if we consider the oceanic impacts due to warming, firstly, there's the consequences of sea level rise and increased storminess. There can be effects on ocean circulation and the Arctic Ocean. Gas solubility changes with temperature. There are some interesting structures, particularly in the Arctic environment, that are called clathrates. And finally, there's a whole series of biological impacts that we can explore. So if we start with these, we look at sea level rise. And if you have a look at this graph on the left, you can see that since 1900, sea level has increased on a global scale by about 19 centimeters. And this comes from two things. One is the direct effect of ocean warming, causing then the thermal expansion of seawater, and that accounts for about 40% of this increase. The other 60% also relates to global warming, but it comes from increased freshwater input from the melting of continental glaciers. If we look at the next graph, this is sea level rise projections. So in particular, this is based on the IPCC different scenarios. And in the extreme case, we can see that sea level rise may be as high as 1 meter by the turn of the century. Why should we be worried about sea level rise? If we look at this map of the world's major cities, we can see most of them, in fact, are on the coast. So all of these are threatened by increases in sea level. In particular, if the worst case scenarios come to be with 1 meter sea level rise by 2100. So about up to 40% of the global population lives in threatened coastal zones. One major city that got affected was New Orleans with Hurricane Katrina in 2005. This was not a direct consequence of global warming per se, but rather a storm surge event. And we know that climate change is going to cause increased storminess, so there'll be increased ferocity and frequency of storm events, including hurricanes. But of course, those will be superimposed in the future on a higher sea level, and so the effects will be even more severe. Coastal flooding has been with us for a long time. This is an early picture, 1953 of Holland, and it's a fairly regular occurrence in Venice. And if we look to the future, flood predictions in the USA, or really North American continent, we can see that there's not a coast that's free of potential impact. So the West Coast, the East Coast, Gulf of Mexico, and even sites in the St. Lawrence estuary. And if we come closer to home, this is flood predictions for Plymouth in 2050. You can see that, in fact, this is where we're filming, is luckily just out of the red zone. But personally, my home is in the middle of the red zone, so future sea level rise is something that I need to take quite seriously. If we have a look at our response, the societal response to flooding is the creation of flood defenses. These are expensive coastal infrastructure. The Dutch, Holland has really got the jump, but we can see also that expensive infrastructure like the London Barrage has been put in place. Not shown here, but also a good example is the protection mechanisms that have been put in place for the Laguna Venice. And without going into detail in terms of the environmental impact, you can see that there's quite huge infrastructures that are being built. These are expensive, and in the future, the question remains as to where we can afford to protect coastal regions. So another ocean response is coastal erosion, and this really is influenced both by storm surges and also sea level rise. So storm surge superimposed on future sea level rise. And we can see a destruction of property. One example is the houses in the coast of Norfolk in the UK. Another example is inundation of the beaches in Miami in the United States. So this shows the Gulf Stream, and fears are any decrease in the downwelling event in the North Atlantic may actually affect the power of the Gulf Stream and the beneficial climate effects that it brings to Europe. And if we look at the North Atlantic in particular, then there's something called the North Atlantic Oscillation, which relates to the atmospheric pressure difference between Iceland and the Azores. And when we have a positive North Atlantic Oscillation event, then we have heat content in the North Atlantic rises. That brings the sea level up, and you can see that that can affect the coastal regions of the United States, the southeast coast of the States, develops stronger westerlies, but it causes the Mediterranean sea level to fall. And in reverse then, when the North Atlantic Oscillation Index is negative, then the heat content decreases, the sea level is lower along the Atlantic coast of the US, but the Mediterranean sea levels are higher. Another effect of global warming is the ice coverage in the Arctic Ocean. So if we look at this graph here, it shows the extent of ice coverage in the Arctic Ocean. The gray is the historic data from the 1980s, 90s, and up to 2010. You can see that since then, there's 3 events that are much lower than what has been the norm. So 2007, 2012, and 2020. So what that graph shows is that there was much less ice during those years than was generally the case. So what are the consequences of an ice-free Arctic Ocean? In the first place, there's shipping. So the ice-free conditions open up new shipping lanes. Not without risk, and certainly the International Maritime Organization is looking at increased regulations for Arctic Ocean shipping. And if we look at the case of the Canadian Arctic, the waterways have not been well surveyed, and so the bathymetric charts in these regions are still quite poor. So again, enhanced risk. There are opportunities likely to come from fisheries, from tourism, and the extractive industries. And if we think about planetary albedo, with no ice, there's nothing to reflect the solar radiation, and the ocean will absorb the radiation. And so that contributes then to the warming of the ocean in the Arctic. And then the question of weather patterns, what will be the new weather patterns as a result of having an ice-free Arctic Ocean? So gas solubility is also affected by ocean warming. If you're looking at this graph, for instance, in particular I want to focus on the oxygen. We can see that as the temperature increases, the oxygen solubility decreases quite a bit. So what are the effects of that in the ocean? Well, it's a global phenomenon, and it really, in coastal regions, there are hypoxic areas. So hypoxic is areas where the oxygen content is really quite low. And in the deep ocean, you have an oxygen minimum zone at 300 meters depth. That's shown in blue on this chart. What happens then is if the temperature increases, the oxygen content at all of these sites will actually decrease. And that puts added stress on marine organisms. And a particular example of that, for instance, would be in the Gulf of Mexico. Now, this is not an event that's related to global warming per se, but would be exacerbated by global warming. And so in this case, the dead zone, as it's called in the Gulf of Mexico, results from farmers in the Midwest applying fertilizers for their crops, and the runoff from the Mississippi getting into the Gulf of Mexico. Turning our attention to clathrates. These are very special ice cages and are important in the Arctic zones. And what you find is that the water molecules come together in such a way that they can trap a molecule of methane within their structure. So as long as they stay frozen, that's no problem. The methane is locked away. But as you get melting hydrates, so as the temperature increases, so these ice structures can break down and release methane. And that's problematic because the methane, as I said before, is a much better greenhouse gas than carbon dioxide. And so again, this is a way of a feedback mechanism to enhance the global warming effects. So shifting then to biological effects, the ocean response. We have a complex set of diagrams here, and from left to right shows different assemblages of marine organisms, from warm temperate species through to subarctic species. And as you go down, you step forwards in time. And so if we have a look then, in all cases, as you step down the curve, you can see that the color areas migrate northwards. And so this is quite typical with the global warming event, that you get changes in the marine ecology, quite significant changes, where whole assemblages migrate to more northerly waters. And one of the other well-known effects for ocean warming is coral bleaching. This is a global effect. It's a heat-induced effect whereby the corals expel the colored algae, and so they turn white. There have been several severe global scale bleaching events that have occurred, in particular in recent years. Ocean acidification, this is called the other carbon dioxide problem. So quite apart from the global warming that we've talked about, carbon dioxide can be dissolved in seawater and it forms carbonic acid. And that carbonic acid dissociates to give you free hydrogen ions, which determines the pH, and bicarbonate. And the carbonate is available for organisms that are calcifiers. In the case where the atmospheric CO2 concentrations increase dramatically, then you get enhanced uptake by the ocean. More carbonic acid is formed and more free hydrogen ions are formed. So that's a lowering of pH, so getting more acidic conditions, and under those more acidic conditions, fewer bicarbonate dissociate to form carbonate ions. So you wind up with fewer carbonate ions, which then creates an added stressor for all of the calcifying organisms. So do we have evidence for the pH effect? Well, this is our trend here of the atmospheric CO2, which is mimicked by the CO2 concentrations in the seawater, and the reverse trend, so a decrease in pH of waters. And you can see that in situ monitoring of these trends only began in the late 80s, early 90s. However, evidence of CO2 affecting oceanic pH. And if we look on global scales, then this is a difference in the pH of ocean waters on a global scale from 1700 until the 1990s. And you can see that virtually everywhere in the world is affected with a decrease in the pH. And in particular, we can see the effects in the North Atlantic and the Southern Ocean. Considering further than the biological effects, the increased acidity reduces the carbonate levels in seawater, and that affects all organisms that are calcifiers, and in particular, for instance, coral reefs. That then is an additional stressor to the coral reefs on top of the global warming. And in particular, then it's a threat for several economically important species: lobsters, oysters, clams, and mussels. So if we consider geoengineering strategies, these have been reviewed recently by GAZAMP. And the Royal Society of the UK defined geoengineering as the deliberate large-scale manipulation of the planetary environment to counteract anthropogenic climate change. And although there's several potential strategies that have been reviewed, I'm going to concentrate just on a small number. So firstly, we'll be looking at enhancing carbon sinks and carbon sequestration, and a couple of the techniques that have been proposed for this relate to ocean iron fertilization or stimulating the growth of seaweeds. Second strategy is enhancing ocean alkalinity, and we'll look at marine cloud brightening. So if we look firstly at the ocean iron fertilization hypothesis, this hypothesis is based on the knowledge that much of the ocean is limited in its productivity because of iron. So there's an iron limitation, and if you seed the ocean with iron, then you can stimulate the growth of phytoplankton. And phytoplankton then at the base of the food chain, so they take up the CO2 and convert it into organic matter. That helps feed the ecology in the upper oceans, the upper waters of the ocean. The only benefit in terms of global warming would be if some of that organic material actually falls through the upper layers of the ocean and winds up getting buried in the marine sediments. So that effectively removes that CO2 as organic matter into the deep sea sediments. This is a very controversial topic, large-scale manipulations of the environment, as we saw with the introduction of cane toads in Australia, doesn't always go as planned. So the question here is, what kind of phytoplankton would actually be stimulated, and perhaps they could be more harmful than good. But moving on, the other idea is to stimulate the macroalgae cultivation, and so this can be in the form of seagrasses or kelp forests. In both cases, the idea then is to enhance the production of organic material through the absorption of CO2 with the aim of having organic material buried in the sediment. So again, a mechanism to remove it from the sort of geochemical cycling. In the case of kelp forests, there is a chance also of removing some of that organic material through to the deep oceans, which are decoupled then from the surface oceans. And we can see then that if this can be applied, particularly in terms of kelp forest, then there's pretty good global distribution of these, particularly in temperate and subarctic conditions. Another way of trying to control oceanic CO2 is through enhancing ocean alkalinity. Alkalinity is sometimes a difficult concept to grasp. It relates to the capacity of a solution to neutralize acid. And so if we're looking at seawater, then the key anions would be bicarbonate, carbonate, and to some extent hydroxides. So enhanced ocean alkalinity raises the carbonate saturation state of the oceans, and that can help reverse the effects of ocean acidification. So as a chemist, I'm going to show you the only chemical equation in this presentation. And in terms of enhancing ocean alkalinity, you can add calcium hydroxide or calcium oxide to the ocean, and it will react with carbon dioxide, and the end product would be calcium carbonate and CO2. And so what this means is the sort of end product, if you like, is you've taken two molecules of carbon dioxide and reduced them down to just one molecule of carbon dioxide, and so hence enhancing ocean alkalinity. Finally, under geoengineering, we'll consider marine cloud brightening. In this case, it's seeding marine stratocumulus clouds, and the whole idea here is that a cloudy ocean is more reflective to incoming solar radiation than the ocean itself. So ideas for seeding clouds, options really depend upon creating a seawater mist, or in some cases experiments are being carried out to look at adding calcium carbonate to the stratosphere. There are new pressures on the ocean, and these are really dependent upon the societal strategies to combat climate change. So some of these techniques can in themselves exert new pressures on the marine environment and marine ecological systems. So offshore energy, not so much in terms of the oil rigs as indicated here, but various renewable energy mechanisms have an impact, as does carbon capture and storage. And finally, we'll look at deep sea mining. In terms of offshore energy, this can be waves, currents, and wind. And all of these have an impact during construction phase and during operation. And during construction phase in particular, there's the problem of noise pollution, and that can actually affect the behavior of marine life. So avoidance behavior in particular has been noted for marine mammals. Once in operation, bird strikes becomes a significant issue depending on the location of the wind farms. And in all cases of these offshore renewable energy projects, there's the possibility of disturbance to the seafloor. In terms of capture and storage, this really is trying to capture the carbon dioxide as it's produced, particularly in power plants or large-scale production of CO2, capturing it. And the techniques that have been utilized, particularly in the marine environment, refer to reinjection into depleted oil reservoirs. So Norway has been looking at this since 1996. Statoil, originally called Statoil, now Norwegian Petroleum. This is not an issue unless the CO2 actually escapes from the reservoir and then can create deleterious effects in the seafloor environment in terms of direct impact on the organisms and also the changing the acidity in quite dramatic ways. And finally, there's deep sea mining impacts. So in the modern age and the technology these days, particularly in terms of battery requirements, there's quite a wide range of strategic metals that are required. And terrestrial sources of these materials are being depleted, and particularly for things like cobalt and lithium, to feed the demand for batteries for cars, etc. in the future, the shortages are anticipated. And so this takes us then to looking at deep sea mining impacts. Seafloor disturbance, again, is the biggest one of this. The threat of leakages and the threat of dust clouds, clouds of resuspended sediments near the bottom of the sea. Finally, I'd like to end on a positive note in terms of the work that the global marine and maritime communities have been doing, and in particular through the UN. So the UN Decade of Ocean Science for Sustainable Development. This is a global 10-year plan that actually started on the 1st of January this year, and in recognition of the adaptation strategies and science-informed policy responses to global change are urgently needed. So in a nutshell, it requires a better understanding and predictability of the ocean in order to have better management strategies going forward. So it's a very ambitious global plan for 10 years, and key outcomes are meant to be a clean ocean that's healthy and resilient, a predictable ocean so we can understand current and future ocean conditions, a safe ocean. This relates to in particular sort of the maritime use of the ocean, a sustainably harvested and productive ocean, so this relates to fisheries, and a transparent ocean. And this really relates to the common heritage that the ocean is for all of us. So this is a very ambitious global plan, and one of the key elements of it is to address diversity, and diversity in all aspects. So that includes rich countries versus poor countries, developing a good gender balance across the domain, and encouraging the early career marine scientists in particular from developing countries. So this is really a global effort with positive outcomes expected, but a long time frame. So many thanks for your attention. I'd be very pleased now to take questions that you may have. I recognize that this is a very broad topic, so there can be quite a wide range of questions coming.
And we're back. So Steve, thank you for that fantastic presentation. I really enjoyed it and certainly learned a lot. And also thank you to the Plymouth Marine Lab for allowing IET to use the venue for filming during the COVID-19 pandemic. Now, we're going to move to the Q&A now, and we have some time for questions. If you haven't submitted any, I would say you could now, and please do so. One question that did come up quite frequently, I saw, was, will the video be available for students? Yes, it will be immediately available after the end of this event. And we also heard about the background music, that some found it distracting, others thought it was wonderful, but it was part of the video, part of the presentation. So I liked it myself, but there you go. Okay, so Steve, are you ready to answer questions?
Yes, ma'am.
Okay, well then let's start with one that came in during the presentation, and that is, isn't mineral harvesting from the ocean for electric car batteries going to cause another major environmental disaster? What would you say to that?
Yeah, well, I noticed that that question came through before I actually dealt with it in the talk. So yes, deep sea mining is an issue. I think there's considerable environmental risk associated with trying to hoover up things from the bottom of the sea, particularly where mining companies are targeting massive sulfide deposits. These are some pretty unique marine ecosystems at depth generally, or on seamounts, so they're fragile. They have fairly weak connections from one deep sea ecosystem to another, and disturbances on the seafloor could be disastrous. I think there's a lot of concern. Even goes back to the 70s, really, when there was the fake stories of Glomar Challenger going to hover up manganese nodules on the seafloor. Plus, I mean, what kind of processing for those ores would happen at sea rather than on land? So there's a lot of reasons to be concerned. The point being that going into the future, there are strategic metals whose terrestrial supplies may be limited. So I think we need to be sure about the processes in place for harvesting such metals. I think, sadly, given human history, I think there's an inevitability associated with it. But I think incredible caution needs to be taken on board.
Great, thanks for that. Let's talk about coastal infrastructures. Now, we know that they're extremely expensive, but I'm wondering what you think about what are some alternative defense mechanisms that we can adopt to counter flooding. And also, I wondered if you could speak about some nature-based solutions and whether they hold promise.
Yeah, so I think in terms of large-scale urban environments, something like the London Barrier is going to be necessary. So this is where you're protecting multi-billion-dollar, multi-billion-pound infrastructure that is of vital interest. In other environments, there are natural things that can be done. And I think in the last couple of decades, there's certainly been a greater appreciation of the value and role of things like mangrove forests along the water's edge. So that's certainly something that can be done, and that helps with respect to protection, particularly from storm surges and the like. But I think there is an inevitability about having to put in place large infrastructure to protect the most important of our coastal environment.
Okay. Another question here, Steve. With the risk of more methane release due to ice cap melting and lower ocean absorption of carbon dioxide, will this eventually lead to a thermal runaway situation where no human response can stop global warming?
Yes, well,
big one.
you can add to that an ice-free Arctic. So all of these are ways that to a potential acceleration of the warming in the future. So I don't quite know what a runaway event would be. but it certainly adds increased complexity to what we have to do in order to protect and try to mitigate climate change going forward. So yes, it is going to make things worse rather than better. I don't know of any, there's no magic bullet for this, so it's a problem. It would be best to try to nip it in the bud and limit warming, particularly in the Arctic, which is warming faster than anywhere else, to maintain as much of the methane in situ as possible. But it certainly, this is not an easy problem to tackle.
A wicked one, I'd say. I have a couple of questions about the Arctic, since you brought up the Arctic, and you may or may not know this one. The first one is, are we expecting more regulations from the International Maritime Organization regarding Arctic shipping?
I don't know if we're expecting more, but they have already put out a polar code that covers quite a lot of things. So anybody interested in this, if you do a Google a search of IMO polar code, you'll get quite a lot of information there. So certainly there's a lot of concerns with respect to the enhanced risks of working in that environment. There's also the question of the legal rights that countries have exerted over those waterways. And I know Canada, for instance, doesn't consider that the Northwest Passage is actually international waters, but the Americans do. And so they rather unkindly send ships through without Canadian approval. So again, the question is going to be there for the Northeast Passage as well along the coast of Russia.
Mm-hmm.
So, but the IMO, I think, is aware of the issues, and there certainly is a polar code in place.
Great, thank you. And a second question on the Arctic. Do we have any concrete data to determine how the Earth's planetary albedo ratio, and maybe while you're at it, you could explain the albedo ratio, how this has changed due to the melting ice in the Arctic?
Yeah, okay. Albedo essentially is a measure of the reflectivity of the planet. So ocean water is very good at absorbing incoming solar radiation, and marine clouds and ice are very good at reflecting the sunlight back into from the surface, and land masses come somewhere in between. I don't have an exact answer in terms of the actual ratio, how it might change, but certainly everybody's aware, particularly Canadians driving in winter conditions, the glare that you get off ice. There was a paper published recently that talked about the heat absorption as a result of the lack of ice cover in the Arctic during the summer, and the proportion of heat compared to just the CO2 effect was quite considerable, something on the order of about 25%. So once the ice cap is removed for considerable periods of time during the summer, then again, this will enhance heating of the Arctic Ocean.
Okay, great, thanks. Some more questions have just come in, Steve. One that's probably fairly short. Is it true that the effects of methane are relatively short-lived compared to those of carbon dioxide?
I don't actually know the answer to that. I guess people are assuming that it may be more susceptible to some kind of photochemical degradation. But methane is a much stronger greenhouse gas than CO2. And I don't know its residence time in the atmosphere compared to CO2. So
Okay.
I shall admit to some ignorance on that. And it's a good thing for students in the audience to realize is that sometimes we don't have all the answers, and you're allowed to say, I don't know.
Good, good. Glad to hear that. This is a Gazamp type question. What are the issues around the leakage of pollutants and waste from shipping, such as hull coatings, lubricants, exhaust gases, etc.? That's rather large, but.
Oh, wow. Well, I can recommend that people buy my book that was published in October called The Environmental Impact of Ships, that was published by Cambridge University Press. I don't think that, it's funny actually, because that's actually the topic that I wanted to talk about today when IET first got in touch with me, but they said, no, we want something on the climate. So it's not a climate issue. There's all kinds of environmental impacts related to, excuse me, related to shipping. The ones that you've listed there are just a few of them. Other ones that relate to noise pollution, which is becoming of increasing concern. The other, in particular, you as a Canadian in the Maritimes would be aware of the number of whale strikes that there are. So there's collisions with mammals and the like. Again, IMO, I think that there's a really good relationship, sort of a circular argument, if you like. New technology is introduced, be that coatings, ballast water treatment, engine efficiency. Scientists then go and tackle and see the efficacy or potential deleterious effects on that. Shippers generally try to comply because they're in open competition with each other. And then where difficulties actually come to the surface, then IMO does respond, albeit it takes some time. But of course, it's the member states that are complying through IMO. So, you know, it's no good blaming IMO for anything if the countries don't actually do what they're supposed to do, right, which is the other misconception that people have about UN agencies, but that would take another lecture.
Yes, it would.
And I know you know what I mean.
Yeah, I have one here about desalination. And I know you didn't really talk about that, but does desalination for water reduce or add to pressures on the ocean?
Well, it depends on the environment in which the discharges occur, because the way desalination works is you take seawater, you remove much of the water, and then you're left with the brine. Now, in some cases, that brine is evaporated in order to get salt or extract particular things like perhaps lithium. But in general, the brine is reintroduced into the marine environment. So you wind up with much more, with very salty conditions. And depending on the subsequent dilution of that very salty mixture, then that can impact local environments. And in particular, I think the concerns would be in places like the Persian Gulf, or the southern side, they call it the Arabian Gulf. The injection of sort of fairly significant brines into waters that might affect coral reefs and give yet another stressor onto the coral reef environments. But generally, people are aware of those kind of things, and engineering solutions can be made to ensure that you're not you're minimizing and mitigating those effects.
Okay, thanks for that, Steve. Maybe you could talk a little bit about the negative impacts of coral bleaching on the ocean environment.
Oh, well, coral bleaching kills off the temperature effect basically kills off the corals. Now, there may be opportunities for those corals to recover. It's not an instantaneous process. And certainly trying to grow corals in the laboratory and then seeding the corals later. There are a few labs in the world that actually have been successful in that, but it's generally not a very easy thing to do. So in an environment where you may get multiple coral bleaching events in successive years, you're really hitting, you're impacting that coral reef quite considerably. And eventually, when you couple that with the ocean acidification effects or other anthropogenic effects, like is happening in the barrier reef with respect to the swamping with suspended sediments, So eventually you're going to kill off these environments. And I remember years ago listening to a talk by Ian Pointer, who at that time was the chief executive of AIMS, the Australian Institute of Marine Science. His parting comment was, if you wanted to see the Great Barrier Reef, go soon.
Yeah, that's yeah, that sounds like an Ianism for sure. I'd like to turn to ocean alkalinity. So enhancing ocean alkalinity through adding alkaline materials like calcium hydroxide directly to the ocean, it's certainly a technique that was covered in the Gassant report. But do we fully understand the full impact of increased ocean alkalinity on marine ecosystems? And maybe you could talk about some of the risks and whether there's research ongoing on that right now.
I think in terms of all of the geoengineering solutions, not just enhancing alkalinity, the first thing to remember is that the scale of the solution has to match the scale of the problem. So the problem for climate change dates back 300 years to the start of the Industrial Revolution. We had the most efficient mechanism you could possibly imagine for making sure that you had a very global distribution of the pollutant, i.e. CO2, as a result of cars driving everywhere over the continent, ships driving everywhere between continents, and airplanes just going everywhere. So in terms of any kind of solution, the scales would have to be massive and so expensive. Now, in terms of would they work, there is research on small scale stuff that's going on to try some of these things. And again, you from Gassant are probably aware more than me of some of the details. But what scares me is that it's a bit of an uncontrolled experiment, much like, you know, Chernobyl was. We don't really know what the effects of enhanced alkalinity would be. And I think the problem here is you're really manipulating marine ecosystems, and we have to be a little bit concerned about whether we're pushing them into directions from which they may respond worse than they do now, and for which may be irreversible. So, you know, I use the example of the cane toads in Australia. That's absolutely classic. They were introduced, you know, to control pests in the sugar canes. In that particular case, nobody at the time had any idea that they would spread across the country and be the disaster that they are. There's lots of examples in New Zealand as well of introduced species. So I think doing things where we don't really understand what the outcome, in my opinion, is dangerous.
Yeah, I would agree with you on that one, Steve. You mentioned cloud generation as a method to reflect a greater proportion of solar radiation at sea. And one of the viewers is asking, what impact would this have on the Gulf Stream and on present weather cycles?
Well, one of the things that I didn't talk about in terms of climate change is the heating in general is accelerating the hydrological cycle. So you're getting enhanced evaporation and cloud formation under those sort of new conditions. The cloud seeding, I don't think would have an effect on the Gulf Stream per se, because that's you know, that's generated by heat, you know, on quite a massive scale. I think the clouds idea is unproven. It's one of those ideas that on the face of it looks good, sounds good, would be easy to try to do. But I recall that there was a famous set of oceanographers, scientists in the 80s proposed something along the lines of relating to the Gaia hypothesis, whereby there may be a natural biofeedback mechanism for producing clouds in the sea to counteract increasing temperatures. So the idea was that biota in the surface oceans would change its composition to favor organisms that produce dimethyl sulfonium propionate, which breaks down to form dimethyl sulfide, which is a gas, so evades from the ocean into the atmosphere, oxidizes to seed clouds, and so that's a cooling effect. Now, there's been 35 years of research on that, and basically I don't think anybody actually believes that theory anymore, although it has stimulated a huge amount of research in the biogeochemical cycling of sulfur, of which I've been a guilty member, benefiting from such ideas.
Okay, this is a good one. This one came in from one of the audience. If you had the resources to pursue just one solution, what would that be? And what would be the biggest benefit? That one's hard right off the top of your head.
Well, because there's no one solution that's going to work. But I mean, to be crass, the solution is to eliminate emissions of carbon dioxide. That's what you have to do. Now, how do you do that? We basically need societal changes in behavior on a global scale. I think Greta Thunberg has got it right. She's a lovely lady who seems to see more clearly at 16 than many people in their 60s. What do you have to do? You have to change the energy mix that we use. You have to improve, you have to use less energy. And part of the ways of doing that is not only with changing what you do, but better insulation in homes, better insulation in heating systems, changing the temperature of your air conditioner in the summer and your heating system in the winter. So it's all of those kind of things. So what would I do? I think the one thing is get society to change its behavior.
Oh, that's an easy one.
Yeah, right.
I know there was a question about seaspiracy roaming around, but I can't find it right now. However, I think it was something along the lines that seaspiracy sort of promotes the idea that overfishing is the major problem in the ocean. What would you say about that, and about the, I guess, the push to not eat seafood anymore?
Well, Seaspiracy, of course, isn't the first doomsday film that's related to this. And, you know, some 10, 15 years ago, there was a film called The End of the Line, which used some of the same kind of ideas. I haven't seen Seaspiracy myself. And I know that I've read reports from eminent scientists who are rather aghast at some of the assumptions that are being made, and in particular basing a lot of information on a paper from Dalhousie about 10 years ago, 15 years ago, that's actually been discredited to a large part. So I think fishing, overfishing is an issue in the oceans. I don't think there's any doubt about that. You can't stop fishing altogether, particularly where it's of importance for artisanal fishermen. I think even I am concerned about some of the factory scale fishing that's going on, and in particular some of the illegal and unreported fishing that's going on. Luckily, we're having better methodologies now with remote sensing to detect that, but we still lack, I think, proper enforcement for it, in particular for some of the vulnerable countries. So, for instance, the whole piracy issue in Somalia sees its origins in terms of other countries coming in and stealing the fish from the local fishermen. So fishing is an issue. I think we need to try to maintain sustainable fishing as best we can, but I don't think a ban on fishing would be sensible from anybody's perspective, particularly if you were encouraging people to eat beef instead.
Okay, Steve, who should we be looking to take leadership on all of this, on climate change and on the ocean?
You know what? I think that's an easy question to answer because we need to look to the youth of today. And I think we need to look at the leadership that somebody like Greta Thunberg gives us. And I would strongly support her for the Nobel Prize. I think it's rather disappointing that she didn't get it last year instead of a president of Ethiopia who then went and created civil war within his own country. So I think it's definitely the youth of today that we need to look to. And I think as well, I'm a very strong believer in the whole UN system, having been in the International Atomic Energy Agency myself for 7 years. So I think we need to look to the work that the UN agencies as a whole can actually offer. They are there for the benefit of all countries.
Mhm.
So, you know, I think the youth and the UN, that would be my answer to that.
Well, that was a good one. I thought I would have stumped you on that one, but I agree with you. I'm wondering, Steve, since we have a couple of minutes left, and you are the ambassador for the UN Decade, whether you want to say a couple of words about the UN Decade of Ocean Science for Sustainable Development.
Yes, well, I'm the IMarEST ambassador. So really, what I've been trying to do with the IMarEST is really test what people think IMarEST can do and highlight actions, contributions towards the UN Decade. And it turns out that almost everything that IMarEST does is of relevance to the UN Decade. There are some things in particular that can be achieved. My particular focus is really on looking at the diversity aspects. And by diversity, I mean rich, poor countries, early generation marine scientists, and other relative academic disciplines that can contribute. So this is by no means just scientists and engineers are going forward with the UN Decade. It's also very important to have the human element there, and so social science is really important. The other thing, of course, is gender, and the whole ethnicity diversity is really important. So what I'm trying to do within IMarEST is again stimulate the youth. I'm really trying to encourage student membership. We want the students to contribute in their own right in the future and have sessions at annual conferences that are student-led conference presentations that are not parallel to the main meeting, but actually are in plenary. So really encourage that mix of scientific ages and disciplines to come together. And in that regard, and particularly to this audience, I would just like to say that student membership to the Institute of Marine Engineering, Science and Technology is actually free. And so students can join for free and can participate in all of the activities of IMarEST. And I know, for instance, there are students that actually chair special interest groups. So, you know, it's a way of promoting their careers and providing mentoring and courses and stuff. So that sort of covers it. And
Yeah, no, that's wonderful. And I know there are others that are online who have watched your talk, who are heavily involved in the decade. There's a website for the decade, so it's not hard to find if you're interested in learning more about the UN Decade of Ocean Science for Sustainable Development. And I think we're about out of time. It's 1 minute to 3 your time and 1 minute to something else somewhere else.
Can I just say one thing, Wendy?
Well, of course.
I'd really like to thank, or PML you already thanked in terms of providing a location for the filming, but I'd really like to thank the couple of guys that spent the day in Plymouth that were filming me. making me do things over and over and over again. And I noticed that I still got a few of the words wrong, as you pointed out to me earlier. But I'd really like to thank the guys there, the production team at IET as well. And I know, you know, they're the ones that made all the graphs go whiz, whiz, whiz. And so I think I'm really pleased with the result, and I'd like to thank them. And thank you as well, Wendy, for actually agreeing to this.
It's certainly been my pleasure. As I said, I think we're out of time now, Steve, but I'd like to thank you. I think your talk was really stimulating. Clearly, the number of questions that came in from the audience is a testament to that. And I'd also like to thank the audience and thank all of you for tuning in and for listening to this talk. Now, there will be another EngTalk in the summer, and the topic is going to be geoengineering in case of emergency break glass. So I would encourage you not to miss it. They're still quibbling about dates, but that information should be available soon. So again, and I'd like to thank the IET folks as well. I think this was a really professional event, and I thank you all for your patience. And although you were exasperated instead of exacerbated at one point, Steve, that's okay. I would encourage the audience, though, to look out for your questionnaire. We always appreciate the feedback. And I hope all of you enjoy the rest of your day, your night, your morning, afternoon, whatever it is. And please stay safe. So thank you all.